Hello everyone, welcome to our next session. This is the ninth session of chapter 5. Let me share my screen first. Today's session we are having Ohad Maislish as a guest speaker, and he's co-founder and CEO at NV0. And today's discussion topic is about how to manage your Terraform and infrastructure as a code. So our guest speaker will give more detailed information about himself and about the company and what about they are doing. But just giving brief information about his background, he's currently co-founder and CEO of NV0, and he's also angel investor. But previously, he also founded two other companies, Arno Software and Capster. And he also took some voluntary activities in Israel. So this webinar is hosted by Guap. Let me go through the agenda quickly. So after my brief introduction, we will we will move to presentation part, and later we will have Q&A and wrap-up sessions. And this is me. This session is again hosted by me. I'm Elvira Sirajzada, doing my MBA at KAIST, joining from Seoul, from South Korea. And our webinars are hosted by Guap. Guap is coming to Driven Open Source Accelerator, and these webinars are only for learning, knowledge sharing, and experience sharing. It's not marketing and selling. And we desire the equality. And we can move right now to the presentation part. Thank you very much for accepting our request. It's a very great honor for us having you as a guest speaker today. You can continue the presentation part.
Okay. Hi, Elvira. Hi, Sako. Thank you very much for having me today. I'm honored to present to your group. Open source is improving the world, and everybody contributes to open source. And I would love to talk about what we're doing at NV0 and focus on infrastructure as code and what happens when you scale with your Terraform or other infrastructure as code frameworks, as we see closely in our company. Okay. You see my screen? We're good. Yep, great. So today I'm going to talk about how to manage your Terraform and infrastructure as code. And I want to say that I've prepared this deck especially for you. I merged a few other decks, so it might be, you're going to see a few different formats in the presentation, but I wanted to talk about different topics that I think are relevant for this group, all about Terraform and infrastructure as code. A little bit about myself. I'm now 40 years old. I have 2 kids. I moved from Israel to California. I now live in the San Francisco Bay Area, specifically in Sunnyvale. My background is technical. I started learning computer science at a young age. So I went to university at the age of 14, in parallel to high school. Then at the age of 17, I worked for Microsoft. It was the first company that I worked for, and I've learned a lot there. And I worked in different other companies later on. Worth mentioning VMware. VMware also revolutionized. Before there was cloud, VMware did the private cloud revolution with virtualization. So I worked there in the early days, which was an amazing experience. Basically, I worked for a startup that was the first acquisition of Israel, the first acquisition of VMware in Israel. Also worth mentioning Revelo System that did nested virtualization technology that got acquired by Oracle. So my background is technical and more focused in the backend infrastructure, automation, and cloud. As Elvira mentioned, this is my second startup, NV0. I also founded another startup named Capster. So if somebody from the audience wants some advice about how to start a company, raising money from investors, all of that, feel free to reach out to me, and feel free to follow me at Twitter at DevOps Ohad. You're going to see some weird slides like that, so it's a pause for me to talk about other things. So this is the website of M0. In a few words about M0, we are automating and managing infrastructure as code. As you can see, we are progressing with some nice customers like MongoDB, PayPal, Virgin Media, and in the DevOps domain, companies like JFrog and Gremlin. With me, there is my friend, co-founder Omri. And also, if talking about open source, worth mentioning Justin. Justin is our VP of marketing, and he was the general manager of Ansible, another famous configuration management framework. So if you want to talk about Ansible, feel free to reach out to Justin, who used to lead and be the general manager in Red Hat of all the Ansible business. About M0, our biggest investor is Microsoft, and with their venture arm, Microsoft M12. So far, we've raised $24 million from those investors. So let's talk about what we're going to talk today. We're going to talk about what is infrastructure as code and what's happening with infrastructure as code frameworks. The basic thing that you need to do with infrastructure as code is Git operations. Basically, you manage both code and cloud resources together. So that's GitOps, and how you control and make sure nothing bad happens in this process and how you govern those deployments. I'm also going to talk about dynamic environments and how there is a new opportunity thanks to infrastructure as code to create dynamic environments and empower developers with the environments per feature, per branch, to test end-to-end their features before they merge it. Another thing worth mentioning, if we talk about open source, is a project that M0 created called Terratag. It helps with cloud resource tagging. And eventually we're going to end with questions. So let's talk about infrastructure as code. A few years ago, your application might have been something very simple, like a monolith and a PHP or Java application with maybe one database. So there were very few items or pieces in your application. Those were big pieces that did a lot of things, and they were simple with their structure. But nowadays, applications became much more complicated. There are two shifts that happen. One is the shift from monolith to microservices, and the other is the shift to cloud native. So you can see this simple example, how architectures look today, and it becomes more and more complicated to manage those with clicks on the GUI of AWS or something like that. So instead of clicking buttons in some GUI of AWS, GCP, Azure, or other cloud vendors, things have moved to code. This is auditable. This is saved in your Git repo. You can collaborate with your colleagues like you share code. And it made developers influence the infrastructure decisions, because it used to be that somebody is responsible for managing the cloud and developers are writing code. Now everything is mixed together because it shifted to code. What kind of code is out there? Terraform is the biggest one. Terraform is by far exploding and growing very rapidly. Worth mentioning, besides Terraform, sometimes we call it its cousin Terragrunt. It's a Terraform wrapper that has some additional capabilities. And another multi-cloud open source framework for infrastructure as code is called Pulumi. You have the vendor specific that are not that open source, like CloudFormation for AWS or ARM templates for Azure. So those are some infrastructure as code frameworks, and every company that decides to stop clicking buttons and instead writing code chooses one or more of those frameworks for the implementation. Let's look at some GitHub projects, GitHub repos of those frameworks. So the biggest one, again, is Terraform. The company behind Terraform, it's HashiCorp. Now they're a publicly traded company. You can see they have more than 30,000 GitHub stars on this framework. It's widely adopted it. It has a very big ecosystem of partners and providers and modules. You can see almost 1,600 people contributed to this open source. So it's widely adopted. And Terraform is just a basic CLI, or any infrastructure as code framework. It has its CLI and the providers. So this is, for example, how you use Terraform to control your AWS with your Terraform AWS provider. This alone has 7,000 GitHub stars and 2,000 contributors, and it grows rapidly. As I mentioned earlier, there is also Pulumi. Pulumi directly competes with Terraform with a different approach. Terraform is more YAML, declarative approach, and Pulumi is the imperative approach. Basically, you write code in Node, in Python, that then executes the cloud provisioning commands. So again, really worth mentioning Pulumi as what seems to be currently the main alternative to Terraform, and also widely adopted with 11,000 GitHub stars. Sako, before the conversation, you've asked me about some trends. So I assume most of the people that heard about infrastructure as code already heard about Terraform and Pulumi. But from what I've seen, only some heard about the new kid on the block. And I think in a year or two, everybody's going to know also about Crossplane, that basically also directly compete with Terraform and Pulumi. So talking about infrastructure as code frameworks, if you are now trying to decide which framework to use, I would strongly recommend also checking Crossplane. They have some great technology and some great advantages. So definitely worth mentioning Crossplane together with Pulumi and Terraform.
I do love, because none of them I really used and heard, so definitely it's Pulumi and Crossplane.
Mm-hmm. Awesome. Another framework that is growing rapidly is specific for Azure, but unlike ARM templates, this one called Bicep, like ARM and Bicep. So the concept here in Bicep, it's similar. It's more similar to Terraform. It's YAML based, but it's only for Azure, but it's open source. If you're an Azure customer and you're considering Terraform or ARM templates, maybe you should also check Bicep.
So if we are in AWS,
if you are in AWS, your options are Terraform, Pulumi, Crossplane, and CloudFormation, which is a proprietary infrastructure as code framework for AWS. So all of those frameworks are great. Basically, if you execute some code, cloud resources are going to be provisioned and updated. But those are just technical frameworks. It's not the business solution that companies need. And we're going to talk about what happens in scale and how you manage infrastructure as code, like something such as Env0. We have our competition, worth mentioning Terraform Cloud as our biggest competition. But I want to talk about the concept, not necessarily about Env0 and what are the differences, okay, between an infrastructure as code framework and a management solution on top of that. So it really reminds us of the difference between Git and GitHub. Okay, Git is a CLI that allows you to save files with versions. But Git, for example, doesn't have the concept of pull requests. Those exist in GitHub. So same goes here with, let's say, Terraform. In Terraform, you cannot really decide who can execute which code on which cloud account. If Terraform code is being executed, that's it. Things happen. But you want to control that. Who can execute which code on which cloud account? How you approve those executions? Who can approve that? What kind of executions are allowed? Maybe there are some policies, not all configurations, maybe creating expensive resources or creating resources that are not secured or outside of the VPC. Maybe it's okay to do that in dev, but not in production. How do I see all of my resources and understand what's going on if there is maybe a drift, maybe the code is in one state, but the cloud resources are more updated. Maybe somebody manually updated the cloud and forgot to update the code. Okay, so those kind of concepts don't exist in Terraform infrastructure as code frameworks. They are pretty dumb. If you want something to be executed, it can be executed. But when you scale, when you have a company, when you have a lot of developers, a lot of cloud resources being deployed constantly, that's when you need a management layer to control that. And basically, it means that without something like Terraform Cloud or M0 or a management solution, by the way, some companies build in-house, and developers are stuck in the middle between the cloud provider and the code. So cloud used to be just cloud resources, AWS, GCP, Azure cloud resources. But now cloud is basically a double-headed creature of both cloud resources and the matching code. Everything goes through the code. It's highly recommended to actually have the cloud vendor GUI disabled, that nobody can actually click anything, but only if you want to change the code, and something that manages that code execution and understands the state in the cloud will help you manage those two entities together. And that's something that M0 solves. And let's talk about why and what are the use cases that companies have when they scale. So they need to automate the infrastructure as code with the Git flows, basically GitOps. When code is being pushed to the main branch, something needs to execute that quickly on the cloud provider. Maybe before that, if somebody just has a pull request of code changes, I want to simulate and make a dry run to understand what's going to happen if I'm going to merge it. So basically, again, managing cloud the new way, both cloud resources and code, and prevent drift. So that's the basic use case, just to automate the workflows of infrastructure as code. The most common use case when companies realize they need a management solution is about governance and control. So they have a lot of infrastructure as code, they have a lot of Terraform, for example, a lot of changes, a lot of deployments, and it's out of control. Again, it's very easy for a developer to influence the infrastructure. You just change code and somebody merge that, and that's it. Bad things can happen easily. Bad resources can be provisioned, expensive resources, unsecured resources, or even more scary, resources can be destroyed easily, like that. You change the code and the resources are being destroyed, and there is no easy way back sometimes. So that's where you need to continue work efficiently. And the only way to achieve that is with governance and control, basically to prevent bad deployments, dangerous deployments from happening. Another interesting topic that I want to talk about is self-service. So you have those Git repos with Terraform or CloudFormation or Pulumi code. And now developers need an environment. Okay, they need an environment for their branch. They need it for just 1 hour or 1 week or 2 days, because they want to test their code. Before infrastructure as code, it means that somebody in the company would probably get a ticket and a request from a developer. I need another environment in my AWS account with 20 EC2 instances, 2 EKS clusters with some namespaces, 1 RDS, 1 SNS, SQS, and 5 Lambda functions. How much time will it take you to create my environment? And it might last forever until you have the DevOps engineer executing that. You will finish developing the feature. Now, all of that code already exists. So basically, we just need an easy way for the DevOps to empower the developers to execute by themselves this infrastructure as code and basically have those environments when they need it, but not for too long, because we don't want massive environments in our cloud account. It's going to cost a lot of money and might create other scale problems. So we want to empower the developers, but still manage that and have some simple limitations on that process. So we want to manage the self-service. That's managed self-service. Let's show some examples on what does it mean GitOps and governance. I'm going to show how this is done with M0, but again, you can look at Terraform Cloud and some other tools that does a similar thing. So let's try to understand what does it mean a pull request with Terraform changes. So this is an example of a GitHub pull request that the developer is about to change some code. So I'm a developer, I added some code, and now I'm asking my colleague if they can help me merge that. So without M0 or Terraform Cloud, or worth mentioning an open source named Atlantis for this specific feature, excuse me, the colleague will be helpless and clueless and will not know whether or not it's okay to merge it. But thanks to something like M0, you can have a dry run and understanding what's going to happen if I'm going to merge that. So it's going to affect this environment, and it's going to create those 6 cloud resources in this environment, and it's going to create 3 cloud resources in this environment. Okay, so I now understand if it's okay or not to merge, and also how much money it's going to cost me. Okay, so that's the difference between just using it separately. Just GitHub does one thing and AWS does another thing. Something like M0, you have the connection and the context of those 2 things, the code and the cloud resources. So those are being managed, and you will only be able to merge that pull request if it passed all of the validations and policies that you've entered. And let's say you've merged that into main and that code is being executed. Maybe in production, you want to have a different check. Okay, so that's how you go all the way after the merge and have some approval workflow. Or maybe somebody just wanted to change some variables value. Nobody changed code, maybe just variables values. That's another thing that is outside of Git. So in any case, in something like M0, that controls the executions, what's called the remote run. So you have somebody that can approve changes. And for production environments, it's really important. So before executing what's called the Terraform apply command, you can have a workflow that basically waits for approval, sends Slack or Microsoft Teams notification for the approval team, for the production team, to say, hey, we have a pending, waiting for approval change. In this case, we see somebody wants to change an EC2 instance from large to medium. Would you approve it? In this case, it's nice. It's going to reduce the monthly cost for this environment, so it makes sense. But with something like M0, you can decide who can do those kind of things. Okay, you can have users that can only see cloud resources and its cost and the logs. You can have planners that can initiate a run, but cannot really deploy. You have deployers, like I've shown here, that can actually approve and apply cloud resources. And you have the admin that can decide who can do what. So those are the basic concepts of M0. Another thing worth mentioning, talking about open source, is the Open Policy Agent integration. Open Policy Agent is another very big open source that allows you to write many rules, also for Terraform, that prevent problematic and dangerous deployments from happening. So let's say a developer now wants to create some cloud resources outside of the VPC. okay, in a place that it's not necessarily secure. So this developer can try to initiate such a run, but thanks to the fact that M0 connects open policy agent and its rules with this deployment is going to be prevented thanks to this validation. Let's see how. So if you look at the code, eventually everything here is in code. So this is an open policy agent policy. In this case, it prevents creating those resources outside of the VPC. So M0 can identify that context. And then when the deployment is being executed, this validation is being executed as well, and eventually will prevent the execution. So before the Terraform apply, this is being prevented. So this is a short summary about how to manage Git with the operations with the cloud resources and how to have some basic governance and workflows that, again, look at the cloud resources together with the code. Now let's talk about dynamic environments. What is a dynamic environment? So unlike a static environment, a dynamic environment is a temporary ephemeral environment that is created dynamically. It goes up and down, it's updated frequently, and it's disposable. You don't need that for the long run. So a dynamic environment is usually used for branches, for pull requests, to test something before you merge. Whereas the static environments are those that last forever. For sure, your production environment is a static environment. You never want to destroy your static environment. And also the staging environment is something that usually never goes down, and it's being updated whenever there is a merge to the staging branch. Sometimes there are additional static environments like dev or QA or demo or support, but usually you know how many static environments your organization has. Whereas the dynamic environments, so we've talked about static environments that are like the production or staging or few environments that you are fully aware of in your organization, whereas the dynamic environments, at any point of time, you can have zero dynamic environment if nobody really needs to test something for a short period of time. Sometimes you can have a lot of dynamic environments brought up and down and throughout the day. So it really depends on how much your developers need to test their features end to end before merging. So those are the terms of static versus dynamic environment. And the difficulty when you have a shared environment is, how do I test my code? Okay, because if you are using one environment, let's say the dev environment, what code is being executed? It can be my code, it can be my colleague's code, but it cannot be for both of us. So at any point of time, it can have just one version of code being executed there. And by the way, that code can be unstable because it's feature being developed. Whereas if you have a dedicated environment, another shared environment, A, you can test your own things without the noise of others. And B, if you have noise, if you have bugs, nobody else suffers from that. Okay, so you can work efficiently and nobody else decreases their velocity, their productivity. Also, you can create and collaborate on a unique DNS entry. So let's say I have a dynamic environment. It has its unique IP DNS, and I want a colleague to work with me on that. I can share that with my colleague. If I don't do that, and I use a static environment, not sure how many of you have seen that, but it has turns. So at any point of time, somebody is using the dev environment, and people ask, who is using dev environment, or who is using environment number 5? So no more inefficiency with that. And if you have a proper process for dynamic environments, you also make sure that it is being updated the same way as production. Because if you have some static environments, who is updating those? Are those updating properly? But if you have a process to create a full environment, full and dynamic environment from scratch, it means that you have a process that does that, and that process is also being updated, similar as production, because eventually in the backend, it's all the same code. It's the Terraform or infrastructure as code that you have that is pretty much similar for your production environment and all of the other environments. This is a screenshot from our product M0 that shows how for each pull request, you can have an environment. Also worth mentioning, another thing in M0 is that we show you the cost, how much this environment cost last week. And I'm going to talk about that in Terratag. Thanks to smart tagging of the resources, you can calculate the cost. As you can see, those pull request environments, PR environments, are very, very cheap for M0, whereas the dev is more expensive. It has more usage. Okay. By the way, this is maybe because we use serverless technology. So in serverless, if you don't really have usage, it's almost free. So that's another recommendation that I have. If you want to have an environment per pull request, an environment per branch, it might get too expensive if you're using something like EC2 instances or Kubernetes clusters, because you pay for those even if you don't use those. So with M0, with serverless, it's a better approach to implement dynamic environments. And with M0, you can see the cost, and you can also limit the number of environments or the budget of those environments and have better governance on that. So that's about dynamic environments. Again, if you want to empower your developers to be able to test end to end, and you already have that Terraform or infrastructure as code in your Git repos, you only need a good way to let them execute that code without creating a damage. The code is already there. So let your developers use that and be more productive. The last topic I'm going to talk about is Terratag. Terratag is an open source by M0 that helps you to dynamically and automatically tag recursively all of your cloud resources. It's very useful for cost purposes, but not necessarily. Let me show you the Terratag webpage. You can go to Terratag.io and learn more about this open source. And there are some examples here and how you tag everything. And you can also go directly to our GitHub. It's not as big as the infrastructure as code frameworks. It has close to 600 stars. But again, it's a great open source if you care about tagging your cloud resources. So a few more things about Terratag. Without something like tags and labels, you have a chaos, okay? You cannot really have organized cloud account without labeling your resources, to associate those to the relevant projects, to the relevant teams, and they're used for many purposes. To understand what happened, who should I talk to if there is a problem, how much things cost, etc., etc. All right. Managing the tags. So without code, how can you manage all your tags? Thankfully, there is code now with infrastructure as code. So Terratag helps you to tag that at scale. Without that, it's a manual process and validation that you need to do over and over. Sometimes there are errors, human errors, and you're not sure if you can really trust your tagging. So that's why we had Terratag. And Terratag allows you to just take your Terraform code and recursively identify which resources are taggable, because not all resources are taggable. Some resources in your cloud vendor cannot be taggable, and it adds those tags automatically. It scans the code, it applies the tags that you choose, and if there are already existing tags, it will not delete those, it will merge those with the additional tags. So that's basically it. You have Terraform code on the left, and you execute Terratag. You can decide what's the name of the tag that you add. In this case, it's for AWS. Terratag automatically identifies the Terraform provider, and it injects those tags into your Terraform code. You have two versions of your Terraform code, before the tags and after the tags, so you can use both options. At NF0, we automatically execute Terratag in each deployment. So this helps you automatically. You don't need to do anything. This helps you later on to organize your cloud resources, and especially to know the cost of each workspace that you have in your Terraform. So let's say you have a workspace with 50 cloud resources, and you have like 5 different workspaces on the same cloud account. By using NF0, you will automatically understand how much each of those workspaces cost, although they are all on the same cloud account. That's basically it. If you want, I can present more features from NF0. I'm not sure that's the purpose of the conversation today, and because we focus more on open source. Let me know if you want to see more about the product, and let me know if you have any questions.
Yeah, thank you, Ohad. I think that will be nice, especially if you can touch the Terraform Cloud versus EMV0, the features, and definitely that would be
the differences between NF0 and Terraform Cloud.
I mean, more nitty-gritty the features. I think that will be great to go. If you want to, as a demo, go and show.
Sure.
You can, because I had a couple questions I just left also that.
Sure. Okay, let's zoom in a little bit about the features here. So
it's managing the state as is in Terraform Cloud. The first question would be, or you create as a workspace and stuff, or it's.
So in NF0, you can let NF0 save the state file for you, but actually we don't recommend that because your state file contains sensitive information, and it's better for you to save it in your cloud account. Okay, it's very sensitive information. So use remote backend like S3 bucket if you're in AWS, and just use that. Another advantage of you managing your own state, but letting NF0 execute the deployments, or Terraform Cloud in that sense, is that in the case of a major downtime, okay, let's say now AWS US East 1 is down. Okay, it happens from time to time, sadly.
Well, I remember.
Let's say twice a year you have a mega downtime. So imagine maybe NF0, maybe Terraform Cloud is also down, and probably your application your product is also down and you want to move something from AWS East 1 to somewhere else, if env0 or Terraform Cloud control your state file, it means that you cannot even locally execute Terraform apply. So in order for you to have less worries if it's security or stability, it's very simple and easy to store your state files in your own remote backend.
Okay, makes sense. So it's more as part of DR and security, you would recommend it, owning it.
That's what we think are the best practices to do that. Yeah.
Okay. And versioning and so forth, do it through the S. That, yep.
Yep. You can just enable that in S3 and you have versioning for all of those files automatically.
Okay. And now I guess the second will be the thing you mentioned about the governance piece. It's how it's going to be in different, this env02 versus Terraform Cloud.
Okay, let's zoom in on the governance. So one basic thing to mention is that env0 has integrated with Open Policy Agent, whereas the default way of HashiCorp of doing things is similar but different. They have another framework or a platform called Sentinel.
Yeah.
And it's pretty much similar to Open Policy Agent with one important difference where Open Policy Agent is open source, which means it's vendor locking. So let's say you write a lot of rules with Open Policy Agent, and then decide you don't want to use env0 anymore, you want to use another product, or you want to use your in-house solution based on Jenkins or Circle CI. You can execute in Jenkins Open Policy Agent policies and make sure you still have this policy as code mechanism. If you use Terraform Cloud and you want policy as code with Sentinel, it will work as long as you work with Terraform Cloud. But then if you decide to move from Terraform Cloud to env0, or you decide to move from Terraform Cloud to Jenkins, what do you do with all the code you've written in Sentinel? It's useless. So it's very powerful. If you are 100% sure, you're going to stay with HashiCorp and Terraform Cloud. Another few concepts that are different between env0 and Terraform Cloud regarding governance, I didn't present that. It's more for the self-service environments. We have time to live and scheduling policies, meaning you can define in env0 that some environments will not run on nights, on weekends to reduce cost. You can decide that developers can provision cloud resources up to 1 week or 1 month, and before it's expired, they're going to get a notification and a warning, and they can extend it. So those workflows of expiry, TTL, and scheduling to empower developers with self-service cloud environments, all those kind of things do not exist in Terraform Cloud. Basically, as I mentioned earlier about the difference between static environments and dynamic environments, Terraform Cloud is very focused on the static environments, whereas env0 supports both.
Okay, so dynamic, you mean more ephemeral environments?
Correct.
I see. And when it comes to the cost piece, how it's going to be different?
You're talking about the pricing of the product, or you're talking about the value that we provide for the customer with their cloud cost?
I think we can mention about the boss, because I also saw that the estimates the cost it gave you. Are you pulling it from AWS API and updating? But maybe it's also
perfect. Okay, so another thing that we do differently. We both have cost estimation. Okay, both products use cost estimation. HashiCorp use their own technology, whereas M0 again integrates with an open source. Where is it? InfraCost. Okay, there is an open source, really great open source named InfraCost. And it's another open source that, are you familiar with InfraCost?
I haven't heard. That's why I am excited to hear that. We had a couple things, yeah, for finance.
Okay, so InfraCost is a great cost estimation framework for Terraform.
I don't know if you have custodian. Yeah.
Cloud custodian.
Yeah.
So InfraCost is for Terraform,
yeah,
and really helpful in the prediction of what's going to happen. But sometimes, you know, how much you're going to pay for an auto-scaling group Kubernetes cluster, how much you're going to pay for Lambda, how much you're going to pay for RDS. You don't know. It depends on the usage. That's why M0 is using Terratag, as I mentioned earlier. So this actually injects those tags into your cloud resources. And if you provide read-only access to your billing API, M0 can tell you how much your cloud resources actually cost over time and correlate that to deployments that might have affected your cloud cost. So this cost over time graph and correlation to the deployments, this exists only in M0.
Okay. So the tagging themselves are more like the static tags, or you are setting the values to the resource level?
Yeah, for each resource that is taggable, Terratag basically crawls on your Terraform code and third-party modules that you use, and basically looks at your code and identifies which tags to inject, and it changes the Terraform file accordingly.
So
that's
my thing is, let's say if resource not yet created,
if what? If your resource is already created?
No, they are going to get created, and they will be randomly generated the name of the, and then you want to add it as a tag. And can you do it like automatically, that let's say you write a code and then tagging you let?
Yeah, so you don't need to take care of it. You don't need to do anything. Okay. You have your code, M0 injects those two tags. Okay, it's called the M0 environment ID and M0 project ID.
Okay.
Inject those tags to all of your taggable resources, in addition to existing tags you might have had already. And then if you add what's called in M0 cost credential, so basically you allow, let's see. Okay, so this is for GCP. If you give read access to the billing API, M0 tries to identify cloud resources with the tags that were injected with a specific environment ID or project ID.
So once resource get created, if you enable the cost piece, it will go add, and you will have this cost posture footprint kind.
Exactly.
I think the interesting would be also for ephemeral environment mentioned. Actually, that was one of the things in our previous shop we end up building. So let's say, as for the developers, will it also be supporting bringing cluster testing and so forth, and then deleting the cluster? Like will it be like for each developer or PR create a new cluster, or just having one bring the Kubernetes cluster, let's say, and separate them on namespace level and so forth, and then kind of deleting that environment?
Not sure I understand the question.
So I would like just to understand from developer's perspective, the ephemeral environment piece. That's
okay. So let's say I'm a developer.
Yeah.
In Env0, the admin can decide on a catalog of templates that are allowed to be executed by the developers. So you have the global catalog. And for each what's called a project in Env0, you have a subset, in this example, of only 4 allowed templates that can be executed on a specific cloud account with specific users and teams that got permissions as deployers to execute that code. And eventually you have a user that has access to this project. And in this project, you have the cloud credentials for a specific cloud account. And this user has permissions to be a deployer and to execute that code. This developer can decide whenever they want to execute several provisioning processes. Let's say in this example, okay, I'm now going to create another environment. I want that environment to be with this kind of configuration or that kind of configuration. Some information is not accessible for me because the admin didn't want me to see some variables values. It doesn't matter. And then I can decide for how long I want that environment. And this one is limited to 1 month. So let's say I want this environment for 1 day, and I want to use that branch in that code. And that's basically it. I now click run now, and Env0 will clone the Git repo and will start execute the workflow. When it's done, then the developer will get an email, will get a Slack notification that the environment is ready, and it has some expiry in those ephemeral environments. As I've shown, there is, in this example, 1 month limitation. So you cannot ask for more than 1 month. Only admins can do that. And you have default, as you saw, unless chosen otherwise. If you just click next, 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 you will get 12 hours. And that's how you easily allow developers to provision environments, but you can also limit them. For example, no more than, in this example, 3 environments per user, or no more than 5 environments per group, per project, per team. Okay, so you can allow them to provision, but not too much. And you can control all of the usage and understand how many environments you have with top users, what is waiting for approval, and so on and so on. Let's look at this environment. It's about to be provisioned. That's it. It's provisioned in 23 hours. It's going to be destroyed. The developer is going to receive a message before that, hey, the environment is going to be destroyed. Do you need more time? Maybe the developer would say, yeah, I need 3 more days. No problem. Until 1 month, you can have 1 month, and you can update it yourself. No need to talk to anybody. So those workflows are very powerful, and it allows the admins, the DevOps team, to empower developers, but still have governance and visibility on that process.
So you can have total cost of the environment, the cost also, and the total.
Yeah. So you have the total cost per project, and in each project you have for each environment how much that costs, and for each environment that cost, you can see how much it cost over time and how deployments affected that. So yeah, so you can zoom in and understand where the cost is coming from.
Okay. That's nice. Is there API for ENV0 available?
Yeah, so ENV0, you have the UI, and you have three other ways to use the product. One is the ENV0 API. The other is the ENV0 CLI, but actually most customers use it with the ENV0 Terraform provider. Okay, so we have our own Terraform provider. And this is the GitHub repo for our own Terraform provider. Like you manage AWS, this is how you can manage ENV0 without going to get the GUI of ENV0. You can add more environments, you can add more templates, you can add and change the role-based access. You can define the modules. We have a private module registry. You can define variables and policies, everything through the ENV0 Terraform provider. And that's because of our customers already use Terraform. They want to manage ENV0 with Terraform as well. They don't want to click any button in any GUI. They want to write everything in Terraform.
Oh, okay. Terraforming ENV0 itself, interesting.
Yeah, like the chicken and the egg paradox.
Yeah, but okay. How about the registry? You mentioned also model registry.
Yes.
So it's the same as a Terraform cloud registry?
Yes, pretty much. This one is pretty much straightforward.
Okay, no difference there. And for the templates, you mentioned a bit, maybe the templates one.
Yes.
Any differences in that flow? Or ENV0 templates?
Template is something to be executed, and module is something to be used in another Terraform code.
Okay,
it's
so
similar, but not exactly the same. Both of them are reusable entities of Terraform code.
Okay, it's more like if you want as a temporary for developers, you create as a template.
Correct. And module is something that developers will write that code using that module. So modules is for reuse of code, and template is to reuse for execution purposes.
I think that's also one more interesting question. How you feel about, because infrastructure, when it's growing and having nested modules, and how you feel and best practices, your recommendation around that, because it can be like module inside the module inside the module, and then it's becoming also hard to manage, and when you break something, and then version and management around it, modules.
So that's why you need to have in your pull requests the dry runs and validations that everything is happening properly. We can have, let me show you, we can control when you execute git push, when you execute Terraform apply. So we have those, just a second, triggers. And you can basically decide if there is a change in a module, you want to be notified about that and execute again Terraform apply and make sure nothing bad happens. So I think when you have something like ENV0, you need to adopt best practices and decouple things as much as possible. We see a lot of customers decoupling their modules, decoupling their workspaces, and then they have some dependencies, but that's good. It's like the shift from monolith to microservices. So the same goes here. It's better to manage a lot of small pieces separately than to manage one giant entity together. Each small entity has its purpose, And in general, it's easier, it's smarter. But when you scale, you just need a proper solution. The open source, just use Jenkins and Terraform open source, you will have problems. But if you use something like env0 to manage those workflows and have the right policies and validations and best practices, that's how you can have both productivity and governance.
Actually, I will also briefly mention some of the listed challenges, at least we face in this level of experiences. So maybe it will be also interesting for you from kind of hearing from the customer side. So one of the things also being regarding debugging, sometimes the errors not the description when you are debugging in Terraform, in local development and so forth. I know, do any your recommendation, or do you think as a you have only your roadmap building around that to make it a bit more easier?
That's Terraform. Terraform is constantly improving. And I remember between the version 11 and 12, there were
Breaking change.
A lot of great additions.
Yeah.
And it continues to improve. But it's not perfect. But env0 is a layer on top of that.
Okay.
It's like, you know, it's like asking a GitHub product about things in Git. So some things should be solved in Git, not in GitHub. Okay. So the same goes here. And there is community. By the way, HashiCorp, as far as I know, they've published about 6 months ago that they are stopping to accept pull requests from the community for the Terraform core. Hopefully, the community can go back and contribute to Terraform soon. But in any case, even HashiCorp themselves are doing a great job evolving Terraform as an open source, and every new release comes with great new capabilities.
Sounds good. And I think this is a bit maybe also on top of Terraform. At least I spent a little bit time, but I couldn't find any good visualization or dependence tracking as well. At least, you know, like if you are in workspace, you want to see like what connect to what. And I think I was doing something, but then also it was becoming very crowded, the visual with .viz I did kind of. So any
visualization and graphs for resources, I think sounds like a good idea, but in reality it's too messy. Okay. What we have in env0 is this resources table that you can see all of the resources that are associated to a workspace. It's not a graph, but it's something that is helpful, because graph is too much information that you cannot understand anything from a graph.
Okay. Sounds good. Yeah, I think it's pretty much mentioned what workspace call what module or what are the in use and so forth. They are more especially when you have new engineers, if you have a bigger code base, where they need to start, which module is doing what, where it's getting called from, are they up to date, and if you have from versions. So that kind of, I'm sure that you're also aware of these kind of challenges, at least, yeah. And yep, and also the factoring piece, if let's say, if you want to move from version to another, and kind of how's the testing piece, like, is it a like thing like for the unit testing kind of thing that make sure that it won't break any part of the infrastructure?
So in env0, you can define a specific execution to be executed in a different version. It's very granular in env0. You can define an execution to be in a specific version. You can define an environment, a workspace to be in a specific Terraform version. You can define a specific Git repo, a folder to be in a specific version. You can define a specific cloud account to be executed with a specific version. So you have the granularity and the flexibility to migrate Terraform versions. It's another challenge when you have Terraform and you have a lot of workspaces and you have a lot of state files, how you do that migration. And you need a powerful tool like env0 to allow you to deploy it, to release it properly. It's very dangerous and risky without it. Just using the CLI,
yeah.
I'm just thinking about how you do those upgrades if you just use a CLI. What are you executing on a terminal? It's how do you test, how you do rollback? It's crazy.
If you have one account, if you are starting, probably yes, even so it's not yes. But if you go multiple accounts, even multi-cloud things, I think getting.
I think if you are one developer,
yes,
you don't need GitHub. You are okay with just executing Git commands. Git clone, Git commit, Git push, that's all you need. But if you are a team and you need to collaborate and you need some governance and history and backup and notifications and integrations and workflows, Git is not relevant for you. That's when you need a solution like GitHub. So same goes here.
sounds good. I think you also already mentioned a couple of the tooling, and I think I did also research. I'm sure that the ones you mentioned that in general that would be into Pulumi. You mentioned crossplane. I haven't get much into, probably will need to check. But I wanted to also ask regarding Terragrunt.
Sure.
And what do you think about them?
We see a lot of customers using Terragrunt. It's being widely adopted. env0, by the way, supports Terragrunt, unlike Terraform Cloud that supports only Terraform. So we have a lot of Terragrunt customers that come to us also because they don't have the option of using Terraform Cloud. Yeah, so Terragrunt has its advantages. I do want to mention, like I mentioned earlier, about Terraform being improved with any new version.
Mm-hmm.
So a couple of years ago, there were more reasons to go to Terragrunt than they are today, as far as I see that. But still, Terragrunt has some capabilities that Terraform doesn't have. So I think it's good to have both.
Okay. And I think one of the reasons I heard was regarding the cost piece.
The cost?
Yeah, the folks moving from cloud to the Terragrunt. Also,
I don't think it's replacing Terragrunt. It's not replacing Terraform Cloud. Terragrunt is a wrapper on top of Terraform. And I think people move from Terraform Cloud maybe to Jenkins and have some workflows with Terragrunt run all, apply all, which is nice, but it's not. You don't have drift detection. You don't have Atlantis workflows or plan on pull request or Sentinel or Open Policy Agent, Policy as Code. Those things don't exist in Terragrunt. They can work, some of them, with Terragrunt, but the Terragrunt doesn't provide this functionality. It provides the Terraform functionality with some basic workflows of dependencies between workspaces.
Okay. See, probably I have one more last question regarding the security piece, because is there like env0 that also doing some security checks, or it's more up to the engineers? Because there are tooling like TFSec or Terrascan, but kind of they're trying to do like static
So we,
analysis.
not surprisingly, we integrate with all of those. And let me show you some examples of our blog. So this is TF-Lint.
Nice.
And also, let's see about, we have, I'm sure we have a blog about Ch05. So Ch05, it's like TFSec or Terrascan. So this is how we use Ch05 and NM0 together. So if you have a virtual machine with OpenSSH, with an empty password, just use something like Ch05 or TFSec, and it will never allow you to provision those.
Awesome. So
yeah, it's very highly recommended to use Ch05 or TFSec or Terrascan in addition to your Terraform code.
Okay, Ch05, actually interesting. So all of them pretty much doing more or less the same. TFSec, Ch05.
TFSec and Ch05 and Terrascan do exactly the same.
Okay, just static security check analysis for the Terraform. And that's kind of most widely used that you will recommend?
Ch05?
I mean, for security static analysis.
Yeah. It's highly recommended to integrate those as well. Yeah, no reason why not to. It's gonna prevent you from doing bad things.
Awesome. Thank you so much, Ohad. You helped me a lot to do my job better because I spent some time doing research and it's ongoing effort, but probably now we'll spend more time after the call and we'll give a try, and we definitely will recommend for the folks kind of listen after, and probably can do small also writing blog and mention about and a bit made details technically. And I just see that it's really becoming more and more integrate with the tooling and stuff, and it's really becoming also hard to track. And that was another thing. My open source idea was also like how we can do like for local development, do some automation around installing all this tooling and then just do around that and more share the all these tooling, which one and do what, so forth. And definitely Terratag and V0 will be in that list. Appreciate your time, Ohad. I know we went a bit over time, and you're always welcome in community, and whenever you have any exciting news, we are happy to share also with the community.
Thank you very much. It's been a pleasure.
Thank you very much. Well, as a part of wrap-up session, let me quickly share your contacts. Just wait a few seconds. Yes, so you can contact to our guest speakers through this LinkedIn and Twitter accounts. Feel free to contact. Thank you, Ohad, for your time, for your interest. Thank you very much.
Thank you very much.